We're now going to talk about systems of equations that are nonlinear, and the first thing that I want to point out is that these have the same rules as before. We have consistent independent problems where no variables depend on any others. We have consistent dependent problems where some variable depends on another variable. And we have inconsistent problems that have no solution. But the difference is that we might be looking at an equation like this instead. X squared plus y equals 3, and 2x plus y equals 3. And so if we have a problem like this, things become a little bit trickier because now we're not linear. We have this x squared floating around. And so one of the methods that we have for using this is substitution. And so what we want to do for substitution is make sure we have a variable that's the exact same in both equations. If we do, then we take that variable and we solve for it in the least complicated one. So I'm going to solve for it in this one. So y equals minus 2x plus 3. And then we're going to plug that in. We're going to substitute that for the y that we already see. So this is going to give me the x squared I already have plus a minus 2x plus 3 equals 3. Well, I don't have anything to distribute, so I'm just going to rewrite this as x squared minus 2x plus 3 equals 3. This is a quadratic equation, so let's first get everything on one side, so let's subtract 3 from both sides. So I get x squared minus 2x equals 0. If I factor this, I get x times x minus 2 equals 0. So this says that my x is 0, and it also means I have an x at 2. I found two different x's. Well, each x is going to have its own y, so I go back up into my y equals, and when x is 0, y equals minus 2 times 0 plus 3, so y is 3, and when x is 2, y equals minus 2 times 2 plus 3, which is minus 4 plus 3, which is minus 1. Now it's very careful. We have to be very careful. It's very important that we write our answers correctly. This is a point, and the 0 here gave me the 3 here. So I get a 0, 3, and I get a 2 minus 1. So this is my answer. It's this set of points, 0, 3, and 2 minus 1. And that's it. Nothing else works. So it's okay to use substitution when you can get a variable that you can substitute for. And what I mean by exactly the same is I'm not worried about the coefficients here. What I care about is the fact that I have a y in both, so that allows me to do the substitution step.